Example problem 2, analyzing geometric sequences. What are the indicated terms of the geometric sequence? The 10th term of the geometric sequence, 4, 12, 36, etc. Well, we know the first term, which we often call a sub 1, or the initial condition, is 4. The common ratio, well, 4 times 3 is 12, 12 times 3 is 36. The common ratio r is 12 divided by 4, which equals 3. So we can use the explicit formula for a geometric sequence, shown here at the left, a sub n, so explicit. Recall that means that we can substitute any value for n, any index term, 99, 2015, and then evaluate to find that term in the sequence. Anyhow, a sub n equals a sub 1 times r raised to the n minus 1 power. And that looks really familiar. It should look a lot like the explicit formula for many arithmetic sequences that we've seen. Anyhow, to find the 10th term, well, our index value is 10, representing the 10th term. So this would be a sub 10 equals our first value, our first term 4, times our r value 3 raised to the index value of 10 minus 1. So let's work this out here on the right hand side. So we know that a sub n, which for us that's going to be a sub 10, or our 10th term in the sequence, will equal our first term, which for us was 4, times our common ratio, again for us that's 3, raised to the power of n minus 1. And again for us, n, our index value is 10. So 10 minus 1, I'll just write that as 9 here. And then evaluate. 3 to the 9th power. Perhaps this would be a good one to work out with a calculator. So we have 3 to the 9th power. 3 raised to the 9th power. Big number times 4. There we go. 78,732 equals 78,000. Oh, now I've forgotten. 832? 732. Oh, very good. So there's our 10th term. Done. Let's move on to B. The second and third terms of the geometric sequence, 2 blank blank negative 54, etc. So we need to know what we would multiply 2 by, and then multiply by again and again to get negative 54. Well, through some guess and check, we could probably figure that out in our heads. I know right away that it's going to be negative, because, well, 2 would have to be multiplied by a negative to give us a negative value here, and then by a negative again would give us a positive value, and it gives us that alternating positive and negative that we see when our common ratio is negative. So let's use the same explicit formula for our geometric sequence, but this time we will fill in the value r. So we know that for us a sub 1 equals 2. We also know that a sub 4, so a slow connection here, a sub 4 equals negative 54. So substituting what we know into the same equation we used before, we'd find that a sub n, we'll call that 4 in this case, will equal our initial value, so 2 for us, 2 times our common ratio. And that's the unknown value. That's what we're trying to solve for. So we'll just leave that as the variable r, raised to the n minus 1 power. So our n value again is 4, 4 minus 1 is 3. This is looking good. So now we do know a sub 4 though. Actually not sure why I wrote that as a sub 4. How about I fix that? A sub 4 is negative 54. Now we're getting somewhere. Divide both sides by 2. negative 27. R cubed. So what value times itself is negative 27, negative 3. To find that, using inverse operations, we would simply apply the cube root to both sides of the equation. The cubed and cube root cancel one another out, being inverses that they are, and r equals negative 3. A quick mental check, negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So we found our common ratio to be negative 3. Now, that makes it pretty easy for us to fill in these two blanks. 2 times negative 3, negative 6. Negative 6 times negative 3, 18. And a double check, 18 times negative 3, negative 30 plus 20, negative 24, negative 54. Awesome. And a chance to show that you have got it. What is the second term of the geometric sequence 3, blank, 12, etc.? Work carefully and make your selection from the choices below.